right, wrapping up our coordinate plane discussion here. We're working on translations today. Final rigid motion, so we're again going to keep everything the same in terms of distance and angles. As we take segment AB off of this graph and translate it, we are going from the coordinates -2, -8, and 7, 4. We're translating by 5 units left and 3 units up. So each point is going to move. They're going to move in the same direction and the same distance. So when that happens, we end up with a segment of the same length. And we end up at a segment that's parallel to the original one, because if the points move in the same direction, then we end up with parallel results. And that's what parts B and C are here to prove. So if you calculate the distance of part B and the distance of AB and the distance of A prime, B prime, you get the same value. If you calculate the slopes of each one, you get the same value. So they work out to be exactly the same. Feel free to pause that and write that down if you wish. We're going to move on to the next section. So, in the diagram shown in exercise 2, we have a kite, which just means 2 sets of congruent sides in sequence. It has undergone 2 transformations. Which sequence of transformations maps the original onto the primes onto the double primes? So if I'm going from the original figure down here in quadrant 3, and I want to go to the primes in quadrant 2, it's in the same orientation that it was before, so all it has done is undergone a slide or a translation. So that knocks out choices 1 and 4 as possibilities, because the first thing that happened was a translation. Then when it moves, if you can tell, it looks like it's been rotated into quadrant 3, but it actually has undergone a reflection, because as you can tell, it goes A, D, B, C, and now it's A, B, C, D. So the orientation has changed. That's how we know that it's been a reflection and not a rotation. So translation followed by reflection is what we want there. All right, on the next page, 2 figures are congruent if a sequence of rigid motions can be used to map one figure onto another. We talked about that back in Unit 2. So with these coordinates, with this coordinate geometry tool, we can apply that. What we see here in sequence 1, well, I've got a couple of examples here. There are lots of different ways that these sequences can be done. What you will see me do most frequently is a translation first to try to map one point that corresponds to another point onto its corresponding place. So I'm trying to take ABCD from quadrant 3 and map it onto EFGH in quadrant 1. So I decided to map it left 10 units first. And by doing that, I end up putting point B underneath point H, so to speak. And point A will land underneath point E as well. So I'm lining it up vertically. And then what ends up happening is it requires a reflection over the horizontal line at 1. So if you follow my cursor here, I'm dragging this parallelogram over to quadrant 4 and then flipping it over the line y equals 1 to make it land. Alternatively, I could translate the original figure, translate this EFGH. I guess I'm going the other way. I'm going from quadrant 1 to quadrant 3. I could also translate this to quadrant 4. Yeah, I described the other one backwards. I described moving ABCD. Actually, I moved EFGH over to quadrant 2 and then flipped it over y equals 1. We also could move it down 7 units, which would line it up horizontally, and EF would be on the same line as BC, and then I'd have to reflect it over x equals 0.5 here. Now, those are 2 ways to do it. Typically what I will do with these, though, is actually something a little bit simpler than this. I will typically take 2 points that I know are supposed to correspond, like say E and A, for example, and translate it so that E lands on A. So that would be, looks like 10 units left and 10 units down. If I go 10 units left and 10 units down, point E would be on point A. And then I would know where the reflection line is because it would be the line that EF and AD share. So typically easier to translate so that 2 points line up. All right, exercise 4. In the diagram shown, triangle EFG can be mapped onto MNP by a sequence. And so if I take EFG from quadrant 2, I can make it land on MNP in quadrant 4. If the first move is a clockwise rotation by 90 degrees, that means that all 3 quadrant 2 points become quadrant 1 points. That's the clockwise move. And you can tell how they moved because point F was at negative 1, 3, so I switched the 1 and the 3, and now point F is at 3, 1. Same thing happened with E, same thing happened with G. So there's my primes. And then what has to happen in order for it to be where it's supposed to go, it's got to undergo a reflection because the orientation is backwards. So I need to figure out where the halfway point is between segment F prime G prime and segment NP. Happens to be at y equals negative 2. So there's my reflection line. Right. And finally, in exercise 5, I want to know which one of these transformations will allow this ABC triangle in quadrant 1 to map onto the triangle that's straddling the x-axis there. So I could just take these one at a time and explain them. A clockwise rotation by 90 degrees about the origin for choice 1 would take triangle ABC and move it into quadrant 4. And then a reflection across the y-axis would take it into quadrant 3. Okay, it wouldn't quite be right. The counterclockwise rotation by 90 degrees would take it into quadrant 2. Reflection across y equals 1. That would be close. But again, point A is at 2, 8. If it goes to 8, 2, it's going to be right about here, so it won't be lined up. Right? Point A won't be lined up with point W. If I reflect over the reflection line here, over this y equals negative x reflection line, and then translate 2 right and 3 up, this is the one we want. Because point A, which was at 2, 8, is going to become negative 2, negative 8, negative 2. They're both going to switch. Same thing with B, same thing with C. And at that point, the orientation is correct, and it's able to just slide into position. Now the last choice, reflecting over the line y equals x, that would be a positive slope line. That would actually go through that triangle, and so the reflection would still be going through that triangle in quadrant 1. And it would not work to just do a clockwise rotation. It would take it down to quadrant 4. So choice 3 is the only one that works. So largely about sequences of transformations in this lesson, and we will work more with these in class.